Our next speakers are from Tresata. This is Katie Levans, and we also have Kuipers, I believe, who are going to present their anti-money laundering application that uses Spark at its core. So without further ado.
Awesome. Is my mic on? You guys can hear me okay? Cool. So good afternoon, everybody. My name is Katie Levans. I'm the marketing director at Tresata, and we build predictive analytics software products that automate the discovery of knowledge and deliver customer intelligence. And so throughout the course of the next 30 minutes, we're going to show you what that means, what all of that marketing speak means. And I'm fully aware at a conference like this and in front of an audience like this that I am totally the opening act for Koert, who is our CTO. He will be the rock star of this. So I'm going to open up and fill you guys in on what we're working on, and then I will hand it off to Koert to kind of explain what we've been working on. So I know that I don't have to tell a room like this that money laundering is not a solo act. The process of cleaning dirty money involves the process of moving funds through a really intricate and interconnected network of accounts. And where that doesn't quite work with current AML solutions is with the current focus on entity level and transaction level scores without looking at this in the broader context of the greater network. So one of the biggest things that we've focused on with Databricks and the power of Spark is adding that network level look to this. So we are going to take a look at why money laundering is just so inherently difficult to deal with and difficult to address. We'll take a look at some of the shortcomings that we see right now and some of what we think we've conquered. We'll take a look at regulatory compliance and why AML is just so top of mind right now, but very difficult to execute and execute well. And then we'll give you a look at what we've done and time allowing and Wi-Fi on my side, we'll give you a demo of the product itself. So money laundering is a massive trillion-dollar problem. Globally, laundered transactions total over $2 trillion. And right here in the United States, we spend an average $7 billion annually trying to stop that. What really stings is that when it comes to actual seized money from successful AML convictions, that totals less than 0.2% of all of those global laundered transactions. So if anybody's keeping score, I think we all know that that is a really horrendous return on investment. So something needs to be done with that. Another issue, this is a big one for me when it comes to money laundering, is money laundering and anti-money laundering is a really broad, complex problem with very far-reaching implications. And so as an example of that, just last month, the Merchant Bank of California, and this is not uncommon, cut off $180 million in transactions to Somalia. So without using just sweeping stereotypes, it is known that Somalia is a breeding ground for terrorist funding. And so that was the fear. They tried to preemptively cut that off and avoid really costly sanctions by just cutting those transactions off right at the beginning. Unfortunately, Somalia is also one of the poorest countries in the world, relying really heavily on remittances for schooling and food and housing and other humanitarian aid. So when we cast our AML net that broad and that wide, we're cutting off the good transactions with the bad, and that's a horrible problem as well, so that's not the answer. And then we would also argue that, I love this picture that I found, current AML solutions are just too dumb. Due to technical limitations, AML is a really slow, expensive, inaccurate, highly manual investigative process. It feels very antiquated. And all the while that you have all of those problems slowing you down, you're also missing a lot of the actual illegal activity, while at the same time delivering an alarmingly high rate of false positives, just adding extra work on top of an already slow, tedious, manual investigative process. So these are all obviously big problems with what's going on right now. When you think about AML, AML dates back to the early American mafia days, but if this is still your image of money laundering, and you still picture that early 20th century mobster getting rich on top of this pyramid of illicit activity, times clearly have changed significantly. Modern money laundering involves this incredibly intricate, complex, complicated horizontal network of seemingly small sum criminal transactions that are built by design to avoid detection by mimicking normal banking activities operating within well-known thresholds. So criminals know what's going to tip the scales to flag them, and so they just operate within those thresholds. And that's a huge problem because then all of those small sums all over the place are accumulating and being used to make the bad guys really rich, but then also to fund really widespread criminal activity from the drug trade all the way to terrorist attacks. So we have all of these huge problems with AML, and we feel that they're not really being properly addressed. So to help combat money laundering, regulatory bodies have placed really heavy compliance and reporting standards on financial institutions. And 4 of those pillars are over here. So customer due diligence, or know your customer, is just exactly what it sounds like. It's the ability to be able to properly identify at a segment of one each customer, which frighteningly is actually not easy to do for a lot of institutions. And so that's a huge problem. There's a new demand for ongoing reporting and being able to deliver that information to law enforcement when it's requested. Tons of regulation and supervision. And then, of course, the end of the road are those really heavy financial sanctions when the institution is unable to uphold those other 3 pillars. So rightfully so, banks and other institutions are pretty concerned about their ability to uphold this new AML compliance. They're getting sacked with these really expensive fines, and they don't want to face that, basically. So in one study, it was an interview of kind of top bank executives and where they see AML compliance going. One of the number one factors they identify are technical limitations to being able to meet their AML compliance. And they also highlighted technical advancements and data enhancements as critical factors to meeting AML compliance in 2015. So this is a huge lag. It's been noted by the industry, and we need a change. We see a number of problems that I've kind of alluded to already here, but I'll highlight again with some of the current AML solutions. First and foremost being poor and unsuccessful entity resolution and identification, and that comes back to that customer due diligence and KYC, know your customer, and institutions being, again, frighteningly unable to identify who each person is at a segment of one. And it's not for today, but Tresata actually does have a really nice entity resolution product that does that really beautifully that we'd be happy to tell you about at some point. Again, as I've already mentioned, a lot of AML involves hands-on human manual investigation time. It's slow, it's expensive, it's sometimes very inaccurate. And there's a lack of being able to automate these systems to pull out and flag what's going on. So on to the good stuff. It's a lot of complaining right now, right? So on to the good stuff. So for the last 2 years, we have been testing a product that we feel is a solution to a lot of the problems that I've just listed here. And a product that would not have been possible 10 years ago, 5 years ago, 3 years ago, because the advent of Spark has really made a lot of things possible for a lot of different projects, this one included. So for the last 2 years, we've been working on this. And when you go back to what I identified in AML as a problem that's too big and it's too broad and the solutions are too dumb, we feel like we have created something that is using Spark that is really fast, really precise, and really smart. And that product is called Teak. And I'm going to show it to you in a second, but I want first to let Koert come up here and talk to you about the actual technical side of that, why we chose Spark, and what that enables for us in the product. So Koert, if you want to come on up.
I have a mic too.
Cool. I'll click for you.
My slide doesn't look as nice as yours, by the way. But I have only 2 slides, and I only want to focus on a small piece of what we do because AML is pretty broad, and it really involves many steps. For us, it involves entity resolution, which we actually don't do in Spark right now, although you could definitely do it in Spark. It involves typically some graph algorithms, think Prego-like algorithms, which we are currently not doing in Spark yet either, but we're actually migrating those to Spark. And then the last piece, once you've done that, is actually look at the results and interactively understand what's going on. And that's what I want to talk about here. So this is the piece that when you talk about AML and you've done the calculations, like flow calculations, right? How is money flowing? You've done entity resolution, so you have a good picture of who the entities are, which is, quite frankly, the bulk of the work. Then there's typically the last step is to actually detect these patterns of what is fraud and how it is executed. And those patterns are changing. I don't want to talk about machine learning to detect these patterns. I want to assume we know a pattern that just popped up, right? Somebody is creating lots of companies. They're all somehow linked to one legal entity, and they do transactions, and then they disappear. Typically, a human being can describe what it looks like, and if you listen closely, it's always a graph description.
We lost it.
Oh. Sorry.
There you go.
Typically, it's a graph description. It's something like this, and I'm going to make it up, but it's a company that has a link, it might be a legal link, to a known offender. It might be in a known country, and it has done a certain amount of transactions that were legal, and suddenly the behavior changed. This entire story can be translated into a multi-hop graph traversal. And this is not a graph traversal in the classical starting from one point. It's more like a look inside this entire graph for entities that fit this pattern. So what we wanted to build for that is an interactive piece of software to pull that up and find these entities. So the conditions were it has to be interactive, because I want a human being to be able to do this and type in these rules and see what happens. It must include graph traversal. We're not going to just do entity resolution. We're not just going to do single hop. So multi-hop, right? It links to something legally. It links to something else with a transaction, possibly 2 hops, right? Money, sometimes they send the money to many little companies and then aggregate it somewhere else again. So possibly a multi-hop relation. The third one, it has to be a search engine. What I mean by that is there's a lot of graph solutions that actually work from a point. You take an HBase, you start from a single point, and then you take Gremlin or something like that, and you work your way from that into a graph. That's a single point graph query. We are not interested in that. We want to be able to describe a graph pattern and search for it across the entire graph. And finally, it has to scale, obviously, otherwise we wouldn't be here. We're currently running at the scale of hundreds of millions of entities, tens of millions of entities, hundreds of millions of edges. It could probably go bigger than that, but I want to stick to that size for a good reason right now. I'll show it in the next slide.
Sorry.
So these are the exact same points I just mentioned again. Interactive, graph traversal, it's a search engine, and we don't want to be limited in size. And I just want to run through them again and now explain why Spark works for that, basically. So first, interactive. There's an easy answer to that. Spark is in memory. The speed with which Spark can do a batch process on a giant RDD is amazing. It's milliseconds. So we actually considered HBase solutions. We considered Spark serialized solutions, but we stuck to fully in memory. So we want this entire graph to sit in memory, and we're not going to do anything less than that. Graph traversal, that's actually the biggest one. So yeah, it's nice that Spark is in memory, but graph traversal is actually a much bigger condition, because graph traversal is a pain. Graphs are, depending on your problem, you need to structure them constantly differently. Every solution has a different graph structure. Graphs have, when you're talking about traversal, they have a very large static structure, right? Everything about the vertexes, everything about the edges. We need all that stuff, but we don't want to modify it. What that means is I want to split my data up. If you start splitting data up on Hadoop, you're going to be dead slow. On Spark, there's the beautiful capability of being partitioning aware. So we can split our graph up into pieces, right? We have a piece that is the vertex information, a piece that is the edge information, and then a piece that is our state. So you can literally think of those as 3 RDDs if you wish. But by partitioning everything and being very aware of your partitioning scheme, you can build this so that it's basically map-side joins and blazing fast graph analysis, where I only have to update the state piece while having access to these very large in-memory RDDs for everything else. And that's really the crux of, actually, I think that was the main reason we picked Spark to begin with. Iteration comes very easy, very important too, because graph traversal is iteration. And with the partitioning-aware RDDs, you can do the iterations really efficiently. Right? It all comes down to having small data flow through the traversals, really to the reducers, and then making sure that ends up in the right location so you can efficiently map site, join it again with the data that you've been working with to begin with. And this pattern repeats itself, and it's basically an effort to minimize the amount of data that flows through the shuffle. Finally, the search engine aspect. I want to be able to process all the data. I don't want to have a single point graph query. Well, really, Spark is natural for that. In fact, it's hard to code a point query in Spark. I didn't have to do anything for that. It comes for free with Spark, and that makes it very suitable for this application. Actually, when we made this slides, we took out the batch processing because everybody thinks batch is slow, but I wanted to keep it in on purpose to make the point. We can do complex graph traversal queries with Spark using batch processing in seconds, and that's what's so awesome about it. Finally, the size thing. Well, Spark scales up. The thing that's interesting about it is that we run 50 million nodes, 500 million edges on our own little development cluster, which is 10 nodes in memory without a problem. It's a couple of gigs, I believe, per node. If you want to get bigger than that, we got to scale up the cluster. We also did extensive testing with making it bigger by switching to serialized in-memory data structures and stuff like that, which is a very viable route if you're interested in it. You can take Tachyon. But for us, it made it about 3 times slower. And since our key requirement was that it's interactive, we stuck to in-memory for this application. That's really it. If Katie's ready for the demo, I'll hand it back to you.
There a go, yes. Cool. Is it this one? Okay. Give me 1 second. I'm just going to get this up. Thank you, Kurt, for walking through all of that. Am I in the right place? Nope. There it is. Oh, this may not scale to this. We'll try.
Just hit the green.
Any experts on how?
Hit the little expand button.
Hit the little arrow. Will it go to the right side?
There you go.
Pretty good. Okay. So I'm losing some part of this, but we'll go ahead and do this. Okay, so what you guys are seeing here is output from Tresata's AML product Teak, and you're seeing it visualized in our real-time graph traversal and query engine, Orion. So you're looking at a consumer data set where nodes are accounts and edges are transaction flows. And I'm going to walk you through, this is actual information, but it's been anonymized. So I'm going to walk you through a demo situation wherein we've gotten a flag for a known fraudulent account, basically. And I want to show you the importance of looking at the network score that Teak provides to you, and not just the entity and transaction level scores, because in our storyline, as you're going to see as we move through this, those two are green. Those would have cleared, and we would have missed this activity altogether had Teak not triggered the greater network complication. So I'm going to see if I can do all of this from not having it right in front of me. So one really cool thing about this product is that you can just save your queries. So someone like me, a business user and not on the tech side, we already have some queries saved in here. This is using Q. It's our proprietary query language, SQL-like in nature. And I'm just dropping the first query in, and I'm going to hit Explore. And sorry about the way this is sized to this, but we just want to give it a go. And so this is what I was talking about. Teak has given us a flag on this account. Her fake name is Carolyn Bount. But as you can see, she's green at her entity level. So we otherwise would not have been concerned about this. So I'm going to take you through 3 more steps to show you why Teak tipped us off to this. So I'm just going to go back into my queries. I'm going to drop in my second step. And what I want to do here is expand out beyond just Carolyn, and I'm going to show you all of her accounts within the bank. And so what we're seeing again here, let me take it down just a little bit, is we've got all of Carolyn's accounts, and again, all green. So we've got her just at her one little entity. We're looking at everything that she's doing within the bank. No need for alarm, right? So let's take it out one more level. We're going to go out another hop and look at any of the accounts that Carolyn is interacting with within or outside of the bank itself. So we've got internal and external, and we're going to see what's been going on. This one's a little bit bigger because we're going to be loading more stuff, but it will be up in just a second. And what you're going to see in this third query, once it pulls up, is this is where things are going to start to get interesting in our storyline. Might refresh it. Let's see if it'll come. Give it a second. No! I told you guys, internet would not be on my side at this very moment. Give me one sec. I hope you're sitting there with bated breath, though, and like desperately want to see queries 3 and 4. They're coming. Okay. Let me get us back in. So this was all the nice stuff I had all set up and ready to go, but I don't mind if you guys see it. So I'm just setting some thresholds here, so we're only looking at certain things. We want just the green ones, no worries. Cool. So this is back where we started. I'm just going to tear through it. And actually just take you guys all the way. So we would have done query 1, query 2. I'm going to move straight to 3. Don't do it to me. Jayesh, any ideas? Oh, okay, perfect. So it's just a little slow.
It's just slow internet.
I have Jayesh, our product guy, here too, in case anything goes awry.
It's not the queries timing, it's the internet timing out.
What's that?
It was the internet
It's
timing
the internet, I know. I just like to call Jayesh just to help me anyway. Okay, so this is our third query. So now we have hopped out. We had Carolyn, all green. All of Carolyn's accounts, also all green. So why would Teak say that there's an issue here? So now finally, and I know in the back of the room it's going to be hard to see, but we'll zoom in a second. I have this one little suspicious red node over here. So now we're going to take a look at why that one red node amongst all of these others and amongst all of Carolyn's transactions and interactions, why that is alarming to us and why that could be impacting her network score. And so to do that, we're just going to do a shortest path query to jump there and see how that red node is related to Carolyn's account. So my last query is just a shortest path query. I'm going to pop that in there. It's going to take a look at it for us. Cool. And so now we can see, and we can kind of drag and drop and expand this out and see what's going on. Let me just set it up like that. You can pin nodes into different areas. But so now we've hit this point where we can see Carolyn, some of her other accounts, and how she's being connected to Alan Burnover, flowing through Carolyn Burnover, and then through 2 kind of suspicious targets of Etta Hill and Danita Hill are the other names that are coming up here. So what we've done is we've taken this really big network and narrowed it down to 3 or 4 names that are suspicious that can now be handed to the investigator to dive into. And in our storyline, what we come to is that Carolyn Bount actually is Carolyn Burnover. Same name, same person, operating under aliases and interacting with Alan Burnover, who is obviously known for fraudulent activities. So that's just to show you guys a little bit about how Q works, a little bit about how it gets visualized, and some of the power of being able to traverse all of this and move through it. But yeah, that's it. So does anybody have any questions for us? Are we okay on time?
Time for 2 more questions. 2 questions.
Kurt, do you want to run up here?
Anyone? We'll start here.
Thank you. So just to clarify, I mean, you're not running Spark live right now, or are you?
We are.
You are. Okay. All right. And
This is running on Spark.
Cool. Thank you. That's all.
It's running on Spark local mode because we couldn't bring a cluster with us, but it's running on Spark.
Yes. So can you feed transactions live in a streaming fashion and pick up real-time and do real-time alerting and monitoring with this?
Well, the answer is yes. It's not what we've done here. This is not real time. These are RDDs. This is not a streaming application. Did somebody swipe their credit card twice, which would typically is a typical fraud case that cashier swipes it twice quickly in a row, which Amex will catch and call you immediately, which I would call event processing, is not what we focused on here. This is on detecting the more complex patterns as they kind of evolve in time of fraud activities that are basically people doing it for a living. This is not catching the real-time fraudulent transaction, which Spark definitely has a role in Spark streaming, and we have a big interest in it, but it's not what we showed you today here.
Okay, thanks, guys.
Thank you.
Thank you.